Yeah, this is the case.
Okay, then I'll go to stick.
What was wrong with that one, Casey?
He's written my name.
I can do the one.
Right, solving trig equations. Once again, we combine everything together that we have done with respect to formulas, and we're going to look to solve trig equations. This will be the last part of this chapter. We'll have a quiz sometime middle next week, and then we'll follow up with a unit test over chapter 6. And then we'll have one chapter left that we'll finish up. Probably be after break, but you know, we're still in line to be able to get through this class and everything done by the end of April. So we're in a good space in regards to timing here. When we're dealing with trig functions, inverse trig functions, you have inverse sine, inverse cosine, inverse tangent. Allows us to solve for an angle. Inverse sine, inverse cosine, inverse tangent. Our click-a-clack on our calculator, we can inverse any of our values. When we take the inverse of a value, we are looking for an angle. We're solving for an angle. Allows us to solve for an angle. It gets rid of sine, cosine, and tangent. It undoes when we take the inverse trig functions, it undoes the trig function. It allows us to get rid of that trig function. Where once again, whenever we're solving equations, if we have 2x is equal to the value of 10, we have to undo the multiplication by 2. We can divide by 2. It undoes the multiplication. If we have x squared is equal to 25, we have to undo the square. So we can undo the square by taking the square root. X is equal to plus minus 5. Well, when we have a trig function, sine of x is equal to the value of 0.5. We have to undo the sine of x. We have to get rid of the sign. Just like we had to get rid of a square, we had to get rid of a multiplication by 2. We have to get rid of sine. Well, how do we get rid of sine, cosine, tangent? Is we use our inverse functions. Okay, so it allows us to undo the trig function. It allows us, when we're solving equations, to get rid of what we need on one side of an equal sign. Because when you're solving equations, you're looking for ways to get rid of what you need to get rid of. Whether it's multiplication by 2, division by 2, squaring, square rooting, whatever, we have a trig function. To get rid of the trig function, we take the inverse of that trig function. We talked about in trig class. When we were in trig class, is principal value. Okay? Your calculator is set up to give you the principal value. So when dealing with your principal values, your calculator does it all for you. Once again, you have a very nice tool to be able to utilize, to be able to work yourself through the mathematics. Your calculator is set up and programmed for the inverse trig values. Inverse sine, you always will be between negative 90 and 90. Inverse cosine, you'll be between 0 and 180. And inverse tangent between negative 90 and 90. When dealing with inverse sine and inverse cosine, you get two solutions. Just like if we have the quantity of x plus 2 squared is equal to 25. And we're looking to solve this equation. And this goes back into the first half of this year. We could solve this equation by taking square root of both sides. So we have x plus 2 could equal the value of 5, or this x plus 2 could equal a second value, negative 5. We have two solutions there. When you physically have to take the square root to solve an equation, which we did there, we must make sure that we get a positive negative. And that could be true for any even root. So we get two solutions, x equals the value 3, x equals the value negative 7. So if I would take -7 plus 2, that would give me -5. I square that and I get 25. 3 plus 2 gives me 5. I square that and I get the value of 25. So we get double solutions here. Well, when we're dealing with the inverse sine, inverse cosine, we also have to deal with two solutions. Okay, and this is, once again, a review of what we did in trig class. When you take a look at the inverse sine, you have your principal value, which is your calculator value, and its supplement. Okay, sine goes with supplement. When you take the inverse cosine, we got two solutions. We got, once again, the principal value. Your calculator will give you the principal value. It will give you a value to start out with, but then we also have its opposite. So when taking inverse sine, inverse cosine, we have to worry about two solutions. Principal value for inverse sine supplement, inverse cosine principal value, and its opposite. How do we find the supplement of the angle? Take 180 minus our angle theta. And when you're in radians, that's the value pi minus the x. So it depends if you're in theta in degrees or x in radians. So you have two different solutions you have to worry about. Once again, when we look at the opposite, I'm hoping that we can handle the opposite. If I get a value of positive 30, invert, I click-clack and I get positive 30 for a value, I also have negative 30. I have the negative or opposite of the solution. So if we take a look at a problem here, we have the inverse, or we have the sine of x plus pi over 3 is equal to 1/2. And we want to solve for general solutions and leave solutions in terms of pi. Okay? Now we could do this one of two ways. You could do it all in degrees and then convert everything back into radians. Okay? Or we can just deal with it in radians. We want to solve for x. We want to get x by itself. When we had 2x plus 5 is equal to 7, we can subtract our 5 over and divide by 2. It was a two-step process because we were getting rid of things that were connected to that value of x. What's connected to the x? Well, the 5 is. How is the 5 connected to it? We have addition. Well, we have to, how do we undo addition? We subtract. What else is connected to the x? Well, we have multiplication. How we get rid of multiplication? We deal with division. What do we multiply by? 2. So we divide by 2. And this is what you learned throughout your algebraic career in solving two-steps equations. This is nothing new to you. This is something that you should hopefully be able to do pretty quick, quite easily in your brain because you've been there, done that so many times. But when we have a sign there of x plus pi over 3 is equal to 1/2, we have to get rid of the things associated with the value of x. Well, what's associated with the value of x is you have a plus pi over 3, and then we have the sign. Well, we can't deal with the problem like we did with our first equation up there by subtracting 5 and dividing by 2, because the sign is connected to everything and groups everything inside the parentheses. So the first thing we need to get rid of is we need to get rid of the sign. So within our calculator, we get clickety-clack through our calculator. How do we get rid of sign? We get rid of sign by using our inverse sign. And if you want to keep it in a degree form right now, that's why I would suggest keep it in a degree form. Take your inverse sign because I want to leave things in terms of pi. I clickety-clack inverse sign of 1/2. And we get a value of what, London?
My calculator's dead.
Oh my goodness sakes. That's an issue.
That is an issue.
30? We get 30 degrees. So we take the inverse sine of 1, 2, so we get a value of 30 degrees. So we have x plus, and if we want to, once again, we can bend our rules a little bit. If we have the value pi over 3, what degree measures pi over 3? 60. So we can say this is a value of 60, and this comes down to the value of 30. But since we took the inverse sine, we get two solutions. Inverse sine, we get our principal value, which is your calculator value, you just did, and also its supplement. And what is the supplement to 30 degrees, Judah? 150. So this x plus 60 could equal 150. Now in both cases, we can subtract our 60 from both sides. So here we have x is equal to the value of negative 30 plus or minus. And over here we have x is equal to 90 plus or minus. Now do we remember what we added and subtracted to our measurement, our solution? Anybody remember? Plus or minus the plus or minus the period end. Our coefficient to x, and we're going to go back to our graphing. Okay, we looked at our coefficient of x to be our b value, and how we calculated the period was 360 divided by b. Our b value is 1, so we have 360 degrees. So now, putting this back into terms of pi, x is equal to negative pi over 6 plus or minus 2 pi n. And here x is equal to pi over 2 plus or minus 2 pi n. Once again, this is a way of us being able to bend the rules a little bit to be able to solve our equations. We have cosine x plus pi over 4. Pi over 4 is what degree measure? 45. How do you get rid of your cosine? Okay, get rid of your cosine from both sides. We have inverse cosine, we have two solutions. We have our Precalc principal value. Once again, you can do things in all in degrees and then convert things back into radians here.
So it's opposite.
Yeah.
Do you want Opposite 45.
Yes. Solution, that's what the instructions are. Back in radians in terms of pi.
Oh, it equals negative.
Plus 45 equals negative 45.
Our inverse cosine negative, or square root of 2 over 2, what do we go down to with that, Zach?
45.
45, so we have x plus 45 is equal to 45, or x plus 45 is equal to, what's the second value? Negative 45. Subtract 45, subtract 45, subtract 45, subtract 45. So x is equal to 0 plus or minus. B value is a value of 1, so the period's going to be 2 pi. So we have 2 pi n. And here we have negative 90 plus or minus 360 n. So we have x is equal to negative pi over 2 plus or minus 2 pi n. So those are our two general solutions. Now, what happens when we have a combination of things that are being put together? We have sine x cosine pi over 4 plus cosine x sine pi over 4 is equal to 1/2. Well, now we just can isolate a variable here, or isolate a trig function. We have sine, cosine, cosine, sine. So what we have to do is we have to jump into our bag of tricks that we worked on the last couple weeks. Do we have a formula that will condense sine cosine plus cosine sine? Sine cosine plus cosine sine. Which one was that? Sine cosine cosine sine. Zoe? Sine of A plus B. Sine of A plus B is sine A cosine B, cosine A plus cosine A sine B, and that's what we have here. So we can condense this back into sine of x plus pi over 4 is equal to 1/2. Once again, if I want to, I can put this into 45, or I'm going to give you a different, something else different that is a different alternative for you. To get rid of the sine, we're going to have to take, once again, our inverse sine. Inverse sine of 1/2, once again, comes down to what? 30 degrees. So we have this x plus pi over 4 is equal to 30 degrees. Well, or what we talked about on the previous slide, this x plus pi over 4 is equal to 150. Now, if we want to, we could take this back and put it all back into radians and work with fractions. You could do either way. You could put them all in degrees and then convert back into radians, or we could just convert back into radians. 30 degrees is pi over 6. 150 would be 5 pi over 6. This would require you to do a little bit more fractional work, but you wouldn't have to do any conversions at the end. We would have this pi over 6. Once again, you could do this either way. We have pi over 6. We have to subtract off pi over 4. We can get a common denominator of 12. So this would be 3 pi over 12. And this would be 2 pi over 12. Multiplying top and bottom by 2 by 2. So we'd be left with x is equal to 2 pi over 12 minus 3 pi over 12, which would give us negative pi over 12, plus or minus the 2 pi n. Now, if you want to keep this in degrees and work with it in degrees, I could subtract 45 and get negative 15 degrees. And then convert negative 15 degrees back into negative pi over 12. You have a choice what you want to do. Okay, you could keep it in terms of radians and just subtract your fractions. Or, to be quite honest, what you could do with your calculator also, your calculator does a lot of fraction stuff for you. You could take 1/6 minus 1/4. 1/6 minus 1/4 in your calculator, hit your math button, hit enter, 1/6 minus 1/4, and you'll come down to negative 1/12. That will give you your negative 1 pi over 12. That's another way of being able to deal with that. Likewise over here, we have 5 pi over 6 minus pi over 4. This would be 10 pi over 12. This would be negative 2 pi or 3 pi over 12. Or if you want to in your calculator, you could take 5/6 minus 1/4. Hit your math button, hit enter, and you'll be able to come up with the same fraction, 7 pi over 12, plus or minus 2 pi n. If you want to work it in degrees and work everything in degrees, that would be fine. And then convert everything back into radians. Or you can just work it in the form of fractions. You choose what you want to do. You do what you feel most comfortable with. Last one, we have cosine squared minus sine squared is equal to negative square root of 3 over 2. Once again, I have two different trig functions. I have cosine squared minus sine squared. So I have to look back into my memory and figure out, remember, what was cosine squared minus sine squared? What was cosine squared minus sine squared? Cosine squared minus sine squared. Cosine 2x. So we have the cosine of 2x is equal to negative square root of 3 over 2. Now we can click it back in our calculator. Inverse cosine of negative square root of 3 over 2. Find a degree measure. Once Once again, get two solutions. Inverse cosine of negative square root of 3 over 2, what do we come up with? Huh? 30?
150.
150. Inverse cosine, got two solutions, principal value and also its opposite. Okay, once again, you could do this either way. You could keep it in this form, divide by 2, x is equal to 75 plus or minus, x is equal to negative 75 plus or minus, but you're going to have to change the 75 back into a radian form in terms of pi. We can also up here (150 degrees) is 5 pi over 6. Once again, the quick transition, if you remember, the transition that I always do is my pi over 6 is 30 degrees. Well, what do I have to do to 30 to get to 150? Well, we can multiply by 5. We multiply by this 5 by 5, so this would be 5 pi over 6. So we have 5 pi over 6 that we have to divide by 2, or we can think of this as multiplying by a half. So we have 5 pi over 6 times 1/2, which gives us our 5 pi over 12. If I take 75 degrees and change it back into a radian form, in terms of pi, I would come back to my 5 pi over 12. Now the one thing we have to watch out for is we've turned our b value back into a value of 2. So the period is going to be 2 pi divided by 2, or the value of pi. So we have plus or minus pi n. You do what you want to do in regards to how do we deal with the radians and degrees of radians. What will happen on a test, is if you just keep everything in the degree form and you give me a solution in the degree form, I'll take you a point off for not putting it back in terms of pi.
I had to for add whole.
By just keeping everything in the degree form.
Get back in with
But once again, the more that you practice dealing with things in terms of a fraction, the more comfortable you'll begin to feel. So my suggestion to you as you go through the homework here, force yourself to get through the fractions. It's not as bad, as intimidating as you think it is, and once again, your calculator does some nice things for you in regards to dealing with the fractions. So, once again, don't be intimidated that I'm leaving things in fractions and put things in terms of pi. Don't be intimidated by that. You have made yourself and you've got yourself to this point in your math career. You have the capability of being able to handle that. It's a matter of pushing yourself a little bit and finishing out the problems in terms of radians, in terms of pi, and deals with fractions. Once again, this is the last of the material. Next week we'll spend a couple days going over the last 3 days that we've just dealt with here. We'll have a quiz, and then we'll do another review, and then we'll have a unit test over the entire chapter 6. And that will lead us a little bit more into our spring break, which is coming up very quickly. I did not realize that. It's coming up very quickly. All right, rest of the time is yours. Solutions, once again, are posted for you.